Good afternoon all, it's Postbag and I've got a couple of boxes today, electronics and module. They're not giving much away. Okay, let's do module. Let's see what's in module. Ouch, something just spiked me. So there's obviously something sticking out on this thing. And it's this module. Oh yeah, it's another one of these little buck converters, although I think this is actually a buck boost converter. I think it's got both boost and buck, probably in series, so it probably boosts first and then bucks, but we'll have a look at that. Some of these components are a little bit wonky. It seems to have suffered in this box a bit. Not surprising, it did get a bit smashed up. Yeah, this one does look a bit thrown together because some of the components just aren't lying flat. That 0.02 ohm resistor is not lying flat, and I'm just so tempted to resolder that joint and just get that thing sat flat. And some of these capacitors are just leaning over at horrible angles. And what the heck is that sitting in the middle of that inductor? There's a component which doesn't seem to be related to this unit at all. Not sure what that is. No, this unit doesn't have a blue 100N104 capacitor anywhere on it, so I don't know where that's come from. Got itself lodged in that inductor. So this has two inductors, which makes me believe that it does the boost first and then the buck. I mean, I suppose it could do the buck first and then the boost, but that wouldn't make much sense because the lowest voltage this takes is going to be, well, I can't remember now, something like 8 or 10 volts. In fact, I'm going to go and get the tablet and look this thing up. So this item is the digital DC converter, CCCV, constant current, constant voltage, power module, LED driver, auto step up, step down. So it's a step up or down. So if I put 12 volts in here, I should be able to get lower voltages out or higher voltages. It was $21.80. I think it was free shipping. Can't see any shipping charge. And it was from Say Love. Yeah, so there's a bit of spec here. Input voltage is 10 to 40 volts. Input current 0 to 8 amps. Output voltage is 0 to 38 volts and 0 to 6 amps. And that's probably why this thing's called a D3806. So the output is 38 volts and 6 amps. So let's put some power to this and see what we can make it do. So minimum input voltage was 10 volts. Currently the sun's out, we've got 13.6. I'm going to have to shield that, aren't I? Actually, I'll just shut the blinds, I think. So this seems to be set to 20.01 something. I think that's probably volts. So that's 20. Now I should be able to, let's just shield that a bit, take the voltage down below my input voltage, which, as I say, is 13.6. And there it goes down. It's not actually switched on, so let's have a look. So yes, 8.78 volts on the output. Let's go up. We can go through the 13 volt point that my input voltage is, and just carry on going and increasing the voltage on the output up to, what was it, 36 or 38? Soon find out. 38 volts. It's interesting. Don't know whether you can hear that, but it's now making some interesting crackling noises at 37.93 volts. Let's stick something on the output. So I've put a 12 volt 21 watt light bulb, car brake light bulb in there. It's currently at around 5 volts, so let's start taking that up. And of course that, now it really is squealing, that's interesting. Now I should be able to take this up to about 15 volts probably. 16, certainly beyond the 13.6 that's coming in. That seems alright, but yeah, there's quite a lot of squealing from the inductors at various points. Take that back down till it's a bit squealy and put that by the microphone. So yeah, you can hear that that's quite noisy. Actually, what would be interesting is instead of this load, to put the electronic DC load that I got the other day onto here. I'll need a 12-volt splitter for the input, but let's do that. Right, I've got the power supply wired up to the DC electronic load, and I've learned a little bit more about this thanks to everyone who's put the instructions for this on the video when this came in. This needs to be in just straightforward DC load mode, so let's switch it off, switch it back on. And no, I didn't do that right, did I? I've got to hold that button. And it says Fun 2, so that's in the battery discharge mode. I'll put it in Fun 1, which is just straightforward electronic DC load mode. I'll have to press that. I'll leave the buzzer on, and then that boots up. Now I'll set the current to 200 milliamps to start with. The voltage, which is my alarm voltage, it's irrelevant really, but I'll set that to 10 volts so it doesn't beep, and so that should be fine. So that should just present a DC load of 200 milliamps to this unit. This has got its output on. Now I've got to be careful here because I've got a sort of loop here, a ground loop. So I'm assuming that ground passes through this, and ground is all one thing, and it's not all going to go bang. But I think it's fine. I will run that. So, are they concurring in voltage? Oh, this thing's all over the place. Probably because this is a switch mode output. So that's saying 12.24 volts. And that's kind of agreeing, but it's a bit high and it's a bit jumpy. Let's look at the current on this that it's reporting. Well, it's not reporting 200 milliamps. This is a bit all over the place. Let's take the current up. 300 milliamps. 400 milliamps. And this isn't reporting that it's supplying 400 milliamps. This is saying it's supplying 160. And the constant current light is flashing on and off like crazy. Maybe this isn't an ideal setup. Maybe I do have a ground loop problem. Wasn't what I was expecting. It's a bit all over the place, isn't it? Let's go back to that. 12.15. This is just jumping around like crazy. Interesting. Well, let's take out this negative wire. That does mean that negative is going to be going through my splitter cable. But maybe that's what's going on. I'll just turn this off. Now, of course, that's beeping because it's seen that the supply has gone under voltage. It doesn't really matter. Let's take that ground off and turn this back on. So that's fairly stable 12.18, and this is still jumping around. So it must be to do with the fact that this has a fairly noisy output. But yeah, that's jumping around like crazy. And this light's flickering on and off. So that's all a bit weird. So I've just dug the scope out because I wanted to see what all this noise was. That pink thing is to try and cover the display a bit. And yes, there's an enormous amount of noise. This is 1 volt per division. So there's almost 2 volts of noise on here. The frequency is really strange. It's 220 hertz. So I'm not sure where 220 hertz is coming from. Now if I change the current that the DC load is drawing, that frequency changes. The amplitude doesn't seem to change much. If I up the voltage of the power supply, that's 15 volts. That's lost sync a bit there. Put the trigger down a bit. It's very strange. I can't imagine that this is entirely responsible for that. I think it's some sort of interaction between the two. So I'm just going to put the bulb as a load back on here and see if the noise disappears. And yeah, with the bulb as a load, just a standard resistive load, not getting that noise. It's hard to see with the bulb on the screen. I'll get the camera a bit closer to the scope. Yeah, so this is just sort of high frequency, very short spike type noise. It's hard to get a a fix on that. Oh, that's better. It's that sort of noise, the sort of digital noise you'd expect from this kind of power supply. So yeah, strange interaction between the electronic DC load and this PSU. But on its own, this power supply seems pretty reasonable. If you don't mind, quite a bit of squealing, that is. 12 volts. You can probably just about hear the squealing. Let's bring it a bit closer because it's making quite a noise. Yeah, so quite a lot of inductor squeal, but it seems to work. It adds another unit to the Ming-He family of power supplies, this one having the advantage that you can have voltages both lower than the input voltage and also, if I go above 13.5, also higher. So yeah, I think it could be useful. Right, next we have this one, electronics from David. Let's see what that's all about. Get this thing open. Oh, this is lots of stuff. Actually, I've got a feeling, I'm not sure if this is Alice. I'll check. Right, let's go through it all. Right, well, there are three things here, essentially. We've got some clipped together boxes with really nice, interesting spring-loaded flip-up lids, courtesy of these little metal springs there. Now, this was really in response to the issue I was having with storing resistors. I wondered whether this might be an option. They do look quite small. I thought these were supposed to be 75mm long, but I'm not even sure that's going to be long enough for resistors. I better get some resistors. So I'll do that in a moment. There's also this, which is, it's a prototyping board, standard sort of unallocated pads on here where you just sort of join them together how you want. But it's got certain things around the edge which are kind of set up for audio. You've got a double RCA jack here, left and right, which presumably fits, oh yeah, that fits in there. There's a switch, there's a pot, I think that's a pot. Oh, why has it got 6 connections on it? Is that a dual pot? Oh, I don't know, I'll have to have a look at that. We've got a headphone jack, actually 2 headphone jacks, so I suppose you could use one as a line in and one as a headphone. And there's also a power connector, DC 2.1mm power connector, which I think must go there. So yeah, that's a little prototyping board with audio type interconnects. And then the third thing is a stepper motor where the driver has been implemented as a microcontroller, and it has an infrared receiver which receives commands from this. Now, I thought this thing had a little LED display on it. Better have a look at the listings on eBay. So these are little anti-static component trays, and I thought these would be ideal for resistors. You can lock them together in sort of matrices like this. I've got 10 altogether. As I say, they have these rather neat little spring-loaded flip-up lids. But the question is, are resistors going to fit in here? And it'd be quite embarrassing if they don't. Well, that looks like it's going to be fine, actually. I'll just cut a few of these off. And yes, they fit in there fine, even with the little cardboard bandoliers or whatever they're called still on them. So actually, these are quite a good size for resistors. Have to find some sort of labeling system to put on the top. But yes, I quite like those. Let's find out how much they cost. So yeah, these were 10 pieces anti-static SMT. Well, of course, I'm not putting surface mount components in here. I'm putting old-fashioned through-hole resistors. Lab chip components, screw storage box case. Now, they were $6.48 free postage for 10, so that's 64 US cents each. That's kind of like about 40 or 50p, I suppose. Now, that's not too bad if you're planning to keep these long term. They are anti-static as well, so you can put ICs in here. How effectively anti-static they are, I don't know. But they do have these rather nice flip lids. I quite like these for resistors. I might get some more of those. So where did these come from? They came from, not Alice, they came from Ianhu81. Okay, next we have the universal, let's get the pencil, breadboard, prototype board, 6 by 10 centimeters, chassis amplifier amp board. Basically an audio prototyping board. That was $5.79 free postage. Now that also came from Ianhu81. And I'm just trying to get this connector in here. This has little white plastic clips which go into these holes cut in the board, but it's actually quite difficult to align everything and get the metal parts aligned without bending them. So I'm struggling a bit to get that in, but that will at some point go in and probably never come back out again. But anyway, that's that thing. The power connector goes there. The 3.5mm stereo jacks go that at one end, and there's one at the other end, which I suppose is fine. So you could have line in, line out, or headphones. The switch is just a big, strange shaped thing, but that fits in there. Yes, that does solder in on those points as well. Oops, everything's falling on the floor. And finally, we've got the pot, which is here. Now that must be, I'm guessing, a stereo pot. It certainly looks like it's got 2 sections to it there, and it has 6 connections. So yeah, I'm guessing that's stereo. And then the final item is this. I've just discovered that the remote has no battery in it, and it's a CR2025. Have I got a CR2025? I don't know. I'm going to have a look. This is one of these 5-wire stepper motors. So it's actually, oh, I can't remember, is this unipolar or bipolar? Does it say here? It says 4-phase 5-wire, 5-volt, stepper motor plus driver board and remote control, speed adjustable. So the little microcontroller on here, which I think was an AT Tiny, must be receiving the infrared commands through there and then setting up the various phases to output to the motor. Now this is one of these stepper motors with a gearbox, so there is some backlash in there. You're not going to get the full sense of the stepping on the output shaft there, but I'll see if I can power this thing up. And yes, I do have some CR2025, so let's take that one out of there and put that in the remote control. Right, now you've got this strange table of commands for the remote control, which is clearly not intended for this. So we've got stop run is on the CH button, so that's there. This is turning at the moment, you can see. If I press stop run, yeah, that does indeed stop. It says forwards is CH minus. Well, I'll have to run first, I suppose. That's running. I don't seem to be able to change the direction. We've got forward and backward on CH minus and CH plus, and that's not doing anything, but the stop run does work. Decelerate and accelerate and auto cycle. What key is that then? Arrow pointing to... Oh, is that these three, the green ones? Oh, that's actually changed the direction. Yes, I've changed the direction using these green keys, which I suppose is logical. That's one way. That's the other. Speed is on plus, minus and EQ. Yeah, that's running slowly. And that's running rapidly. I wonder if we can hear that. I put that near the speaker. That's against the phone. Minus. Where's the... Oh, the remote's there. Oh yes, I can hear that. Well, I can feel that changing. I presume that sound is going through into the phone. Okay, well that seems to work for speed. What other functions are there? Oh, inputs 1, 2, 3, 4, 5, 6. I'm not sure what they are. There are a couple of extra pins on here, so maybe you can switch these pins on and off with the remote control. Yeah, that's quite a weird thing, really. Bit strange, but I suppose it is an introduction to stepper motors. Be interesting to see the output shaft from the actual motor. Maybe I could tear this down and have a look at the output from the stepper motor rather than the gearbox. If you're wondering what this is, it's just a Arduino Nano baseboard, but it has a 5-volt regulator on, so I'm just using it to turn my currently 13.5 volts down to 5 volts to power this little board. So that's the rather curious 5-volt 4-phase 5-wire stepper motor. That was $8.18 free postage, and that came also from Ianhu81. And that's it. These are today's Postbag items. Cheerio!